All right, what's happening, guys? Today's going to be a two-parter, so let's settle in. Here we go. Today we're going to apply properties of rational exponents. We're also going to do some stuff with properties of radicals, too. That's typically what I like to work with, but you guys need to be pretty skilled with both of them, especially the properties of rational exponents. So let's get this copied down. And here we go. So now this guy right here, you've messed with this before. Let me show you an example. If I have something like this, x to the fifth times x squared, okay? You know that this, since the bases are the same, you know it's going to be x to the power of 5 plus 2. You just add those two and you get x to the seventh. Okay, so as long as the bases are the same, you're going to add the exponents. In this case, it's a little more challenging because the exponents are rational, they're fractions, okay? So all you have to do, you notice the bases match, so write it down, 7, and now add the exponents. So 1/4 plus 1/2, okay? You could probably do this in your head. That's a quarter plus a half, that's 3/4, right? So we get 7 to the power of 3/4, okay? Typically, if you can't add those in your head, you need common denominators, right? So you go times 2 times 2. Okay, now it's 1 plus 2 over 4, right? And that's where we get the 3/4. All right, so that's just a quick, easy one. It's supposed to be easy. Let's look at this guy. Okay, this is going to be 6 to the power of 1/2 times 8 to the power of 1/3. Okay, all raised to the power of 2. All right, so now there's a lot going on in this problem. Okay, if you look right here, you should know that this is actually the square root of 6, and right here, this is the cubed root of 8. Okay, and if you think about it, the cubed root of 8, well, you can actually get a value for that. You can evaluate that, right? What times itself 3 times is 8, and that's 2. So we can simplify this a little bit. Let's just go ahead and do that, okay? And we can actually switch the order of it too. I could put that 2 out in front because this turns into a 2, so that's a 2 times, this is the square root of 6. I'll just leave it as 6 to the 1/2, okay? And it's all to the power of 2. Now, again, you've done this before. Watch this. If I put something like this, 3x squared times y all to the power of 5, okay? You distribute that 5 to everything in there. So this is going to be 3 to the 5th power, x to the 2 times 5 is 10th power, and then we have y to the 5th power. Okay, you're just kind of distributing that. That's kind of a poor choice of words, but anyway, that's what you're doing there. So we're going to do the same thing here. It's 2 squared now, okay, so it's 2 squared, and you know that's 4, and then times 6 to the 1/2. Well, 1/2 times 2, that's 2 over 2, which is just 1, so we're left with 6 to the power of 1. All right, and now we have 2 to the second power, that's 4, times 6 to the first power is 6, and 4 times 6 is 24, okay? So again, a lot going on in that problem, and these are just kind of the basics that I'm just kind of guiding you through. We're going to do some simplification later in the notes, and it's going to get pretty challenging, so make sure you're up to speed with this. Again, you could watch my video over and over as many times as you like. Let's try another one. I think it's kind of similar. We have 4 to the 5th power times 3 to the 5th power, that's a good sign, all to the power of negative 1/5. Okay, now there's a couple ways we can do this. All right, I like to start off with the parentheses, okay? Inside the parentheses. If you notice, this is 4 to the 5th times 3 to the 5th, okay? The powers are the same. So if you wanted to, you can really write this as 4 times 3 to the 5th power, like that, all to the power of negative 1/5. Okay, and so now what we have is 12 to the 5th power, okay? So 12 to the 5th power, because 4 times 3 is 12, all to the power of negative 5th. And now you can multiply those two together, and we get 12, right? Now 5 times negative 1/5, that's just going to be negative 1. And 12 to the power of negative 1, what does a negative exponent do to your base, okay? All right, you write the reciprocal of it. So instead of 12, it's going to be 1 over 12. All right, and now the negative power of negative 1 turns into a positive 1. So that's going to be your final answer there. All right, now this is probably coming back at you really fast, okay? You worked with this last year. If you were in honors, I think you probably worked with it quite a bit, but in regular, you guys probably just kind of breezed on through. So you guys got your work cut out for you. Again, if you have any questions, you need help, see me in office hours, stick around after the Zoom. I'm more than happy to help you guys, okay? All right, let's do a couple properties of radicals. All right, so we have, let's just go ahead and title this Properties of Radicals. Let me watch the time real quick. Okay, we're at 5.5 minutes. All right, we're doing great on time. All right, here's our first example. All right, it is the cubed root of 12. Okay, now I know a lot of people, they'll read that and they'll say 3 square root of 12, and that is, couldn't be further from correct. Okay, so this is the cubed root of 12. Okay, what times what times what is 12? Obviously it's not a whole number, so you can't go in that direction, but we'll talk about this in a sec. Times the cubed root of 36. Okay, now I want you guys to notice something. Notice I'm taking the same root of this 12 as I am of the 36. You've seen this before, kind of. If you look back up here at this example, remember this is 4 to the 5th power and 3 to the 5th power. The powers were the same, so I was able to combine those two, right? Multiply them still to the 5th power. I can do the same thing here. As long as the roots are the same, then I can multiply the 12 and the 36. So what I'm going to do is put it under the same roof, I guess, root, okay? And we got chickens coming in. Hello, chickens. All right, and then let's see, we have 12 times 36 inside, okay? All right, now what I'm gonna do, because we need to simplify this, I'm gonna break it down, okay? I'm looking for cubed roots of these numbers, okay? Now there's a bunch of ways I can do this. I'm just gonna kind of show you one way that might work for you, okay? And later I might show you a different way, okay? So if I break down 12 into prime factorization, we have well, we know 4 times 3, but then it's 2 times 2 times 3, right? So a 12 is 2 times 2 times 3, right? 2 times 2 is 4, times 3 is 12. Then we have 36. Isn't that 6 times 6? But 6 is 2 times 3, right? So we have another 2 times 3 times 2 times 3, all right? And if you look, we have a 2 times a 3, we have a 2 times a 3, and we have a 2 times a 3. We have 3 6s, 6 times 6 times 6. Here, I'll show you another way. Watch this. If you don't like that, I'm just going to put it in order. We have 2 times 2 times 2 times 2, right? There are 4 2's under there. And then we have 1, 2, 3 of the 3. So times 3 times 3 times 3. Okay? This might be easier to see for some of you guys that are rusty. All right, so look, I'm looking for cubed root, like what number times itself 3 times, okay? So check it out. I have 3 of the 2's right here. So that's gonna come outside that radical as a 2, okay? I have 3 of these 3's right here, so that's gonna come outside that radical as a 3. So 2 times 3, not 23, okay? And then we still have a 2 inside there, so that's still inside that cubed root. So we have the cubed root of 2. So this is gonna be 6 times the cubed root of 2, okay? So there's a lot going on again, and I know it's been a long time since you've worked with anything like this, so this is going to be a beast for you guys, but you'll be all right. Just hang in there. Let's try this one really quick. We have the 4th root of 80 divided by the 4th root of 5, okay? And this one might look kind of imposing, but it's actually not going to be that bad. Notice I'm taking the 4th root of both of those numbers. That means I can write 1/4 root and then divide those numbers. So 80 divided by 5. You notice that? See how here I was taking the same root, so I was able to do the operation multiplication. Here the operation is division. Since I'm taking the same root, I can just put them together. And 80 divided by 5, if I'm not mistaken, that's 16. And that might look familiar to you, okay? One cool thing is to get familiar with your cubed roots, your square roots, and even maybe your 4th and 5th roots. 2 is a good number to have memorized because, you know, you can memorize the 5th root of 32, that's 2. Okay, the 6th root of 64, that's 2. So the 4th root of 16 is going to be 2, and we're done. If you don't know that, just break that down into prime factorization, okay? That's going to be 2 times 2 times 2 times 2. There's 4 2's and you get a 2. Here, watch. If you missed that, watch. The 4th root of 16 is 2 times 2 times 2 times 2. I'm looking for the fourth root, so I need 4 of them to multiply. Hey, look, there's 4 of them right there, so that turns into a 2. There's nothing left inside the radical, so you're good to go right there. You don't need to write fourth root of something else, like you did over here. Remember, there was still a 2 left, so we had to write down the cubed root of that 2, okay? All right, so that's that on properties of radicals. Let's see if I could squeeze in a couple challenging problems of trying to write expressions in simplest form, okay? Let's start part C and then I'll stop the video and begin again later. All right, here we go, part C, simplest form. All right, so here's our first example. We have the cubed root of 135. I'm gonna sharpen my pencil. All right, now this is one where you can just break this down. If you look, it's divisible by 5, right? If it ends in 5, it's divisible by 5. So go ahead and break it down by 5. Watch, cubed root of what, 5? Just take your calculator, 135 divided by 5. That is, let's see, 27. So I know that 27 times 5, okay? And see, I recognize this number. I recognize 27 right there. That's because I've been doing this forever, okay? But if you don't, that's cool, okay? Watch this, break it down. What number times what number gives you 27? A lot of you are like, oh, 9 times 3, that's easy. But think about 9, what is that? That's 3 times 3. So 27 is 3 times 3 times 3. You notice something? 27 is a perfect cube. All right, and then we still have times 5. And look, we're looking for 3 numbers. Okay, we got them right there. So that is a 3, and we still have the cubed root of 5. Okay, so that's going to be simplest form there. All right, let's do another. I'm going to try to get in a couple more before I'm out of time here. I have 3 more minutes. Let's see, we have the 5th root of 7. This might, yeah, actually here, I'll start the next video with this one because this one's pretty crazy, all right? So let me just do another one like this. The cubed root of 108, all right? We'll stop with this one. The cubed root of 108 times the cubed root of 4, okay? Now look, we have the cubed root of both numbers. So I'm gonna write it as 1 cubed root, okay? And then I could still go 108 times 4, but I'm not gonna do that. I know 108 is divisible by 2. Let's check to see if it's divisible by 4, okay? Well, 4 goes into 108. It looks like 27 times. Hey, there's that 27 again, okay? So we got 27 times 4, all right? And then we still have times 4 right there, okay? Again, if I'm going too fast, just stop the video, rewind it, okay? All right, now look, let's break this down. We're looking for cubed roots, so numbers times itself 3 times. So if you don't know these in your head, that's fine. I'm just going to do it step by step. 27, that's 3 times 3 times 3. 4 is 2 times 2, and the other 4 is 2 times 2. And look what we have. We have these 3 3s, and we have these 3 2s. So that comes out as a 3. That comes out as a 2. If we're multiplying 3 times 2, that's going to be a 6. So we have 6, and then we still have that cube root of 2 left that we can't do anything with, okay? All right, so that's that. I'm going to come back to this. I'll see you guys in a second. Peace.